to Math 105. We are talking about Chapter 2.1, Simple Interest. So what is simple interest and how does it work? Think about the money in your bank account that you might have right now. And each account has a specific interest rate that over a certain period of time will help it grow. The increase in that value while it sits there is called the simple interest that is gained. Now this has an equation. I'm going to change my stylus here. INT, this stands for your interest, is equal to PVR times T. Now this is only for simple interest. Simple interest. So if INT is labeled for interest, then we have your present value, PV. This can also be called your principal or your initial or your starting value, your original value, something that just says you have this right now. Then you have R, which is rate, and T for time. Now, interest also has another equation, which I prefer a little bit more over this one. So your interest is equal to your future value minus your present value. Now, this goes for any sort of period. This is great for simple. And more specifically, we'll learn compounding. You can use either one when it goes for this section. I'll be using this a lot more frequently because in the past, a lot of students have forgotten that they can't use this for, they cannot use this equation for compounding, and it sometimes gets lost in translation. So you're going to be seeing me do this one a lot more frequently. Now I defined future value on that last one, and now on this one, this is future value. It could be called maturity, your final value, anything that says or suggests that it's going to be worth something in the future. We already know this to be present. Okay. So for an example, find the simple interest on $5,000 investment earning 8% per year for 4 years. Now, right now we don't have a future value to go off of and subtract your future from your present. So instead, we're going to have to use this equation. Again, that equation is specifically for simple interest. So if we know your interest is equal to your present value times your rate times your time. Well, your present value is your value that you have right now. Your interest rate is 8%, and this is going to be specifically for years. And your time, they said, was for 4 years. I like to label everything so I know where to get started. And one thing I'm going to really hit home on is that your rate and your time always need to match. So this being years and this being years, we have no clash or transition that we need to make or conversion. So we can just throw it into your equation times your rate. If you're not familiar how to do your rate, all you're going to do is you're going to take the decimal place that's typically found here. And you're going to move it over twice. So we're working with 0.08 times your time 4. Now for me, you can use any sort of calculator. I'm going to be kind of flipping through a lot of them in class just to kind of show you. Desmos is a good one at times. However, it doesn't do a whole lot. And Desmos has a lot of different types of calculators. You'll see the rightmost Desmos is a graphing one. The one next to it is scientific. While you can use that and it's really good at times, there's also this one. I think I went a little too fast. There's that blue calculator there that says calculate 84. That's also a really good one. So I'll show you this one first. So it's 5,000 times 0.08 times 4. And then you get your 16,000 or 1,600,000. So that is just having your money sit in the bank that it actually made $1,600 by just not having to do anything with it. So let's try it again. So this would be a great time for you to pause the video and practice here on your own. It says, find the simple interest on a $100 investment earning 0.5% per month for 7 months. So one more time, PV is equal to $100. Your rate is 0.5%, and this is per month. And your time is in 7 months, which is great because, again, they still match. It's okay that it's no longer in years. That's fine. The end goal is that these values need to match. They have to have the same units. Now, be super careful on some homework, some quizzes, some tests. You might see it where it already looks like it's the decimal place has moved. But if they're telling us that that is a percent, you need to move it still twice over. So we're really working with 0.005. So 100 times your rate, 0.005 times 7. And I'm going to show you a different calculator this time. I will show you Desmos Scientific. Now, Desmos Scientific doesn't have everything that we need. It has a good portion of it. So I'll show you either way. How many zeros? 2 times, what was it? 7. I tend to forget the values that I need if I don't have it with me. And so notice that you'll type it in and your answer, it says your answer below, or your answer shows up on this side. Now that little fractional button here that you're seeing, you can also put it into a fraction, and notice it'll be a reduced fraction. So that is a nice feature, and I'll show you the same on your graphing calculator if we do encounter a problem like that. So 3.5. Oops, I have so many apps open, it's hard to tell. Oh my goodness. There we go. 3.50. And this is, again, just the simple interest that has been earned on your account. So that's how you calculate your simple interest. Now we're going to calculate your future value. So we can also predict your future value in the account if you have the right information. Now, future value, we can do a number of different equations. So your future value is equal to your present value, so something that you have in your account initially, plus the interest that you may have earned. So just because they didn't ask it on the last 2 questions, we could still figure it out. So if we look for future value here, we could say, well, it's your present value of $100 plus the interest that was gained on the account. So your future value in this case would be $103.50. So this is one way to calculate your future interest. And that goes for all of those values. This also has another equation. It has the present value plus, now your interest we broke down as its own equation, present value times rate. I'll do it like this, times rate times time. However, it's a little redundant sometimes if you have your present value listed twice. So depending on your algebra skills, you may have learned how to factor something out that they have in common. Don't worry, I don't expect that of you. Instead, we factored it out. So taking your present value away from both of them will have the remaining of 1 plus RT. Now, this is the one that you most frequently will use, but just know you have more options. So in example 3, it says, what is the value at the end of 4 years of a $5,000 investment earning 8% simple interest per year? Now, one thing I will point out, some of my students who are now taking their final, they're getting a little hung up, or at least starting to study for the final. They're starting to forget some of the simple things. Make sure you're looking for keywords like simple interest, or in our later sections, if they don't say anything about compounding or payments or deposits, you're just working with something that is just basic. So they have given us your present value of $5,000. Your rate is at 8% simple interest now per year. And your time is 4 years. Perfect. Again, make sure that these match. We haven't seen one that hasn't matched yet, but we definitely will. So if we're asked to find the future value, I'm going to be using the value below because we haven't been asked to find your interest yet. So instead, we can use the given information. So we can do 5,000, 1 plus your rate. And again, we didn't move the rate over. Don't go too fast. I know this seems really elementary, but I see a lot of students on their last try on their test make a mistake. And I would definitely enter it into your calculator this way, or perhaps you can get rid of this parentheses and just multiply here. Okay, but definitely use parentheses to your advantage because sometimes your calculators, they don't understand what you really need. So let's throw that into your calculator, whichever one. I'll go back to this one. I'll try and flip-flop as best I can to show you as much of these calculator differences. So I'll do it like this one to start. Not Desmos, but this graphing calculator is nice, depending on the one that you might have at home, if it's a physical one, which I definitely recommend. It might already tell you that you need to close a parentheses, because notice I opened one right before the one, which means I need to close it again on the other one. Going to hit enter to get to 6,600. Ooh. There you go. Now here you are asked to find the total interest paid. So you can do one of two things. If you know to calculate your interest this way, you could do it one way like this, or you can do it as if you know your future value is your interest or your present value plus your interest, then you can subtract your present value so that you get your interest alone. This is probably the one that I'm going to be using because we haven't seen this one quite yet. 6,600 minus, I think we started off with what, 5,000? So the interest that is earned is 160. There you go. All right, let's keep moving. So again, a nice place for you guys to pause and try on your own. It says in December 2015, Radius Bank was paying 1.10% interest on savings accounts with a balance of $2,500 or more. If the interest is paid as simple interest, find the future value of a $2,500 deposit after 6 years. What is the total interest paid? So they have told us that right now in our bank account, we have $2,500. We have a rate of 1.10%. And this is, I'll actually write, this is per year, which then converts, again, moving it over twice, 0.011. If you wanted to tack on the 0 following, that's okay. T is equal to 6 years, which again, these match, we're good to go. So we want to find the future value, which we're taking your present value. We're adding 1 plus your rate times your time. So 2,500 times 1 plus 0.011 times 6. Maybe something like that goes into your calculator. Show it on this side. 25. Oh. 2,500. Oh, come on. There we go. 1 plus 0.011 times, what was it, 6? Closing that. We get 2,665. 2,665 for your future value. So it says find the future value, and then it says what is the total interest paid? So if we know your interest is equal to your future value minus your present value, this is the one I'm going to recommend you use most often. We're going to take what we ended with and subtract by what we started with, which is $165. Perfect. Again, another one for you to try out on your own. So again, pause the video here. It says when moving to another location, homeowners sometimes have to buy a new home before they sell their old house. One way to cover the cost of a new house until they get the proceeds from selling the old house is to take out a short-term bridge loan. Suppose the bank charges 12% simple annual interest on such a loan. How much will be owed at the maturation? This is a fancy way to say the maturity, the future value, the end. If something is mature, they have grown up, they were older, right? They're at the end of a 300-month bridge loan of $90,000. On this one, be super careful. All right, so they've told us how much is in your bank account. They said we got 90,000, or on your loan, so sorry. Your rate, they said, is 12% per year, which is 0.12. And your T is equal to 3 months. All right, 3-month bridge loan. Notice that you have years here, but you have months here. So since they clash, you now have to convert. Mostly you convert your time into your rate, but it doesn't matter in the big scheme of things. So in our case, if we have 3 months and your rate is in years, right? We're going to say 3 months over 1 year has 12 months, which is 1/4 or 0.25. Now you can use either of these values, but this is now in terms of years. So now that they are in the correct value, we're going to be using either 1/4 or 0.25. It does not matter which one you use. So they say your future value is equal to your present value, 1 plus your rate, 0.12, times, again, it doesn't matter. I might choose to do a decimal place on this one, maybe a fraction on the other one, up to you. All right, I'll show it on this one. 90,000, 1 plus 0.12 times 0.25, and close. So our future value is 92,700. Okay. A couple things just to note in case they are in different contexts again. There are in 1 year, there are 12 months, there are 365 days, and 52 weeks. Those are the ones you're going to see most often. So we just need to make that conversion in case you see it. Now, selling bonds are one of the primary ways companies and governments may raise money. Okay, the bonds work. Oh, there we go. What is a bond and how does it work? It says an investor can buy a government or corporate bond, which is to lend them money. You make money from the interest payments and by selling it for more than you paid for. However, you can also lose money if you sell it for less than you paid for, or if the issuer defaults on your payment. So at times you can either make money or lose money. So if you're noticing that you have less than what you started, that's okay. It's not that you did anything wrong. It just means that this was not a good investment to have done. So with that in mind, example 6. The Megabucks Corporation is issuing a 10-year bond selling an annual rate of 6.5%. If you buy $10,000 worth of megabonds, how much interest will you earn every 6 months? How much will you earn over the lifetime of the bond? Okay. So they're telling us, oops, wrong color. Your present value, we said, was $10,000. Your rate, we said, was 6.5% per year, which can convert to 0.065, right? Just move that over. I like a visual. I always see that a little bit better. So there are 2 questions going on here. One says when T is 6 months. So we have a clash, we have months, we have years, which means we need to make a conversion. So 6 months, and there are 12 months in 1 year. Now notice that whatever you have, even if it's days or weeks, you're going to put your value up here and then divide by however many like value it is in a year. So if this was days, let's see, 52 or 30 days would be 30 over 365, or 13 weeks, so then 13 over 52 weeks, things like that. So make sure the yearly amount is on the bottom and your amount is on the top. So you have 1/2 or 0.5 years. So now that they match, we are good to go. So in our first problem, it says your future value is equal to $10,000, 1 plus your 0.065 times your 0.5. Okay. And I'm going to let you guys practice punching that into the calculator without me. Let's see, actually did. Oh, even better. I just noticed it says how much interest. So did you guys catch my mistake? How much interest? And am I finding my interest or am I finding my future value? So actually, I don't need my future value unless I want to calculate it. So this is actually not necessary. Instead, I mean, unless you wanted to use the other equation, right? If you found that, you could do future value minus your present value, or we could say it's your present value times your rate times your time. Now that one might be a little bit better to go because it's just requiring a lot less work from us, but play to your strengths. If you'd prefer the other equation, that is totally okay. So put that into your calculator, see what comes out. And I put one too many parentheses as I was talking. Okay. So that's if we're working with a time frame of 6 months. So if we were to change it, but now have the lifetime of the bond, right? Well, how much did it say was the lifetime? Not for forever, but instead for 10 years, a 10-year bond. Now, because this is in years, we now have a matching value, so this works out for us. So we're going to repeat that process one more time. $10,000, 0.065 times 0.5. Oops, not 0.5, 10. Copying the other problem here. So 6,500. All right. Keep in mind, just note that when the time and rate do not match, make sure you convert one into the other. Let's try it again. Now we've been working a lot with future value, so now we're going to try it with present value. So it says we can go in reverse by finding the present value of a future value amount. So in our case, we're working with, actually, I'll show you how to convert. So right now we have future value is equal to present value 1 plus your rate times your time. So that's what we have seen quite often, but this is when we have, or we don't have your present value, which you're still going to be seeing. So if that's the case, if we need our algebra skills to isolate this variable, and this is all in one parentheses, we can actually go ahead and divide both sides by that in the parentheses. It cancels on one side, and then on the other side, you're left with your PV. So our big equation, PV is equal to your future value, let me move that over, all over 1 plus your rate times your time. So let's get into your next problem. It says an investment earns 2% per year and is worth $30,000 after 17 months. How much did you have originally? So a lot of students get hung up on a question like this. Use keywords. Originally. How much did you have originally means your future value. What is your present value? So sorry, I may have said future. What is your present value? Present value is your original, your initial. Whereas when it says something like worth, well, if it's worth $30,000, right, that is your future value, right? It's being projected to be worth this amount. So in this case, we have your future value of $30,000. You have your rate as 2% per year. And you have your time, I think, which was in 17 months. Right? You got months, something that we don't want. You got years, they clash. So let's make it like not clash. So we have 17 months divided by 12 months. Now you're going to come up with a number that's obviously greater than 1, which is okay. All that matters is that this now is in terms of months. Now you can leave it as a decimal or a reduced or as a fraction. So if we have PV is equal to FV over 1 plus R times T, then we're going to plug everything in. 30,000 divided by 1 plus, and our rate was 2%, 0.02, right? 1, 2, there we go, times 17 over 12. All right, I'm going to switch to this calculator. Notice that you can just hit enter and it'll pull up with your own. We said 30,000 divided by 1 plus, you have 0.02 times, and I would put parentheses again for any sort of division, 17 divided by 12. And what's nice about Desmos is it tells you how many parentheses to close. Sometimes your calculators don't always do that automatically. So we have 29,17,3. 29,17,3. 29,17,3. And what was that? 4, 2? No. Oh, I hit the same one. 4, 2. So when you're rounding, just simple rounding. So notice that you're rounding to 2 decimal places. They're going to say to the nearest cent. 419, the 9 is going to boost that 1 up. So if it's 5 or more, you're going to round up. If it's 4 or less, you're going to keep that number. There you go. Interest rates. So fees, if we're talking about loans, fees on loans are can also be thought of forms of interest. So if we were to try it again, it says example 8, a 2-year bond costs $3,000 and will pay a total of $100 investment over its lifetime. Ooh, actually, did I want to do this? I forgot why I put this in here, and I think it's because we're going to see it in our lab. Sorry, I took it out a few semesters ago, and now I added it back. So a 2-year bond costs $3,000 and will pay a total of $100 investment interest over its lifetime. What is the annual interest rate R as a percent? Round your answer to 3 decimal places. So they're telling us it costs $3,000. So right now it's going to cost us $3,000 and we'll pay a total of 100 interest over its lifetime. So interest is equal to $100. Oh, not 1,000, 100. Your T is equal to 2 years, and we do not know R. So let's figure out. Right now, the only formula that we've seen so far that has your interest, your present value, your time, and your rate is the one with your interest. PVRT. Now, we don't have this R, but we can go ahead and plug everything in if we wanted to. $3,000 times R times 2 years. Now we can go ahead and multiply the 3,000 and the 2 on one side to get 6,000 R, and we want to get this R alone. So we're going to divide $6,000. And we could put it into your calculator at this point, which it's probably going to want it to be a decimal. But some rules of thumb, some quick algebra stuff, if your numbers both end in some zeros, the zeros can cancel out, but you can only cancel out the smaller, the smallest amount of zeros. So this one has 2, this one has 3, you can only cancel out 2 of them. So R is 1/60, which let's place that into your calculator and have your calculator round. So we can do 1/60. Actually, I'll show you. I wonder if this will do it. No, it probably won't. 1/60. So when you go to round, when it says 3 decimal places, that means 0.016. So if we end on that 6, look at the one right next to it, which is also a 6. That's going to tell us, are we going to increase or decrease? So 6 tells us we're going to boost the following 6 up. So 0.017. So rounding to 3 decimal place, and then it says place your answer as a percent. So now we get to move this over 1, 2. So 1.7%. Okay. Now your next part is extra credit, which you can read down here. Summer students, if that applies to you, you're gonna upload it into week 1. If you're in just my regular face-to-face class, you're just gonna submit your answer and the work to me the next class day.